Well, welcome to the Headless Dam with Cloudinary Bootcamp, course lesson number 5, an introduction to image formats, today presented by Jan Sneyers. He's senior image researcher at Cloudinary. I have a great interview with him. If you want to learn more about him, just check out the introduction section of this course on headlesscreator.com. So without further ado, Jan, welcome. Glad to have you here.
Thanks for having me.
I'll let you get started. I'm going to give a warning to people. You know, it's post-COVID days. We all have family at home. If we hear little kids, hey, that's the way it goes today. So we're all good. Have fun, man. It'll be fun.
Thank you. Okay, so today I'm going to try to give you a little guided tour in the world of image formats, and there's quite a lot of them, and you might be wondering, why are there so many different formats, and why are there different formats in the first place? So the way I've structured this is in 3 parts. First, I'll talk about different types of image formats. Then I'll dive a little into color spaces. And then finally, I'll try to give an overview of all the different formats that are out there. So let's get started with the first part. So the different types of image formats. So one big axis of differentiation is in authoring versus delivery. So in a typical scenario, you have a workflow where you start by capturing or designing an image. So an authoring step that may take multiple steps of editing, adjusting, maybe multiple people. And this is the part that is typically where you really need a DAM system to manage these assets. But then at some point you have a finished image and you want to deliver it. And this is where the CMS or CDN or both come into play in order to get this image delivered to the end users. So each of these steps in the workflow has their own formats. And so this is one axis of differentiation between the different formats. Are they aiming at authoring or more at delivery? The purpose of a DAM in general is, of course, to do things like access control, search, categorizing, indexing, managing workflows, managing versions, and so on. And a generic DAM can do this with any kind of file. It doesn't necessarily need to know whether it's an image or a Word document or whatever. But some DAMs have more image-specific functionality, and they can do some things that are only relevant for images. So the simple examples of this are to extract metadata about images automatically instead of having to enter it manually. So things like dimensions, color space, or any metadata that is embedded into the image file like EXIF or XMP. So to automatically extract that metadata and have it available in the DAM so that you can search on it and so on. But it can be more complicated than that. It can also be AI-based object detection so that it can identify what is in the image and add the relevant tags automatically. Or it can figure out what are the predominant colors in the image, detect duplicate images, things like this. And if you go even more advanced, then the DAM can also start doing some kinds of image processing. So in particular, one basic feature that is, of course, very useful is to generate preview thumbnails so you can get a preview of the image without having to download the whole file, which might be quite big. But it could also be converting between different image formats, or even to combine different image assets and crop them maybe, or overlay them on top of one another, maybe using templates or maybe using transformation chains. So the amount of functionality around images can be quite different depending on the DAM system. And the most advanced DAM systems are basically an end-to-end integration where they also can do the delivery part. So instead of having two separate systems, one that does the asset management and one that does the delivery, and there's a strict separation between them, it could be part of the same system where the images that are uploaded in the authoring phase can automatically be turned into images that can be delivered. So that's one aspect of it, authoring versus delivery. The other aspect is raster images versus vector images. So raster images are based on pixels, and this is the most common type of images. Vector images are based on drawing instructions, so they basically contain shapes and lines, and they still need to be drawn in order to turn them into images that you can view on a screen. So vector images, they can be rasterized, turned into pixels, and then you can view them. But the other way around is not really possible. You cannot, in general, take any raster image and turn it into a vector image. Of course, there are tools that try to do that, but for photographic images, it's not really going to work. The main advantage of vector images is that they can be scaled to any dimensions. They don't have any intrinsic resolution, so they can just be scaled to whatever resolution is available and remain crisp. Whereas raster images, they have their fixed number of pixels, and if you want to see them at a bigger dimension, they will start to get blurry or pixelated. So if possible, you should use vector images, but this is only going to be possible typically for non-photographic images like logos, text, illustrations that are drawn in a vector drawing program. So it's not always possible, but if it's possible, it's best to stay in the vector domain.
Quick question, Jan,
sure.
for you on the vector images. Do most browsers support vector images?
Yeah, all browsers support SVG. So it is possible to use vector images on the web. Of course, if it's a really complicated vector image, it might still be worthwhile to rasterize it and serve it as a rasterized image, because a very large SVG file will not only be heavy to transfer, although that can be alleviated a bit with compression, but it will also be heavy to draw and it will slow down the page rendering. But for simple things like logos, it's a very good option that is available in all browsers. Yes,
I see, and that's something important to keep in mind too. Then, even if you want a huge vector image, which usually is pretty quick for download, the rendering time could take a little bit longer, right? So it could slow down the rendering of the page.
Yeah, the rendering is basically more or less dependent on how many drawing instructions are in the file.
Right.
So if you just have a few lines, it will be fine. But if it's a very complicated image, then yeah, it might be an issue. Yep.
Excellent. Okay, cool. Thank you.
So I'll mostly focus on raster images because they are the most common and they can be used for any type of image content. But just to emphasize, if you have a vector image, then it's best to keep it as a vector image and even serve it as a vector image as well. So when you talk about raster images, you have to realize that images are a lot of data. Sometimes people say a picture is worth 1,000 words, but if you do the math, 1 pixel is actually 3 bytes at least, and a screen full of pixels is easily worth 1,000,000 words if you compare it like that. This is uncompressed. Of course, if you compress images, you can bring down the size, and this is very much needed because otherwise images would be way too heavy to be used on the web. There's 2 main types of compression, and this is also a way in which image formats are different. Lossless compression is basically taking an image and preserving it exactly, mathematically exactly. So this is what you can do if you want to be sure that there's going to be absolutely no compression artifacts. With lossless compression, typically for photographic images, you can get a compression ratio of 2:1 or maybe 3:1. So what would be 3 megabytes can become 1.5 or 1 megabyte, but it's still going to remain quite heavy with lossless compression alone. Exception is some kinds of non-photographic images. They can be sometimes compressed very well with lossless compression and get reduced to acceptable sizes. But typically for photographic images, lossy compression is used. And lossy compression is basically, the lossy means that you're losing information, but the idea is to do it in a smart way. So if everything goes right, you're only losing information that is invisible anyway. And so these algorithms are applying clever tricks in order to avoid visible compression artifacts, but still reduce the sizes of the files a lot. And in lossy compression, you can typically do 20:1 or even more compression. But of course, this discarded information that you lost when doing lossy compression, it can no longer be recovered. There's no way back. So it's a one-way street.
Quick question on lossless, because I've worked with compression apps where I end up doing lossless, and the compression is very minimal when you look at the final size, right? So when really would you do a lossless compression versus a lossy compression? Because also when I've done lossy compressions, I lose a lot of the quality of the photo, even if I play with the parameters a lot. It's visible sometimes. When would you when is the optimal time to use lossless compression?
Well, I was just going to get to that basically.
Okay, I jumped ahead. I'll let you take over.
Yeah, no worries. So basically, the problem with lossy compression is that, well, it loses information, and especially during the authoring or the production of assets, this is problematic because you will want to save your image multiple times while you're working at it, and each time you do a lossy compression, the artifacts will tend to add up and be cumulative. So you get a kind of photocopier effect. If you do repeated lossy compression, the quality loss will build up. So during authoring, you basically always need to use lossless. Either just uncompressed if you're working locally and you don't need to transfer anything, compression might not even be needed. Or if you do compression, only lossless compression, so that you don't risk getting any artifacts. And so the best practice is to only do lossy compression at the very end, just before delivery, and only do it once. And of course, this is something that in practice doesn't always happen, and you often see this with memes that get like shared on Facebook, and then somebody downloads it from Facebook and uploads it on Twitter, and then they bring it from Twitter to Instagram and so on. And as it traverses all these social networks, these websites do lossy recompression. And so you get many generations, and this explains why some of these memes that really go viral in the end get a very poor image quality. This is caused by this photocopier effect, or this generation loss. So this is something definitely to avoid in any professional workflow. One other aspect of image formats, and this is in particular for delivery formats, is progressive decoding. So this means, can the image be rendered on the website before it's even completely downloaded? And so there's basically three kinds of images. Some images will only load when they're completely transferred. So you need to transfer the whole file, and then the browser will decode the compressed image and show it on the screen. There is also what you see at the bottom here, an incremental kind of rendering, and this is very common, where the image will load top to bottom, as it's being transferred. So the top of the image will be transferred first, and the browser will show it as soon as it has that data. But there's also what is called progressive rendering, which means the whole image, a preview of it can be shown quite early, before when only 10% of the data has been transferred. And then the quality of the image will improve as more bytes arrive. This is in particular important on slower networks, of course. If the network is fast enough, it doesn't make much of a difference. But on some mobile networks, the connection can be quite flaky or slow, and then having a progressive rendering can be a very useful thing in an image format. So those are, I think, the main different features that the image formats can have. I have some links on further reading on these things like generation loss and progressive decode that I think you will find in the course notes.
Yeah, we'll add it under the bonus material. Real
Yep.
quick, Jan, on the progressive rendering, is
Yep.
this metadata that is stored in the actual image that says it should be progressively rendered, or is this done something programmatically through code?
So this is something that the browser does, and it can do it because of the way that the file is organized internally, technically. So instead of storing the data top to bottom, it stores it in a kind of way where you get a zoomed out version of the image basically first, and then gradually get more detail, so that the order in which the data will arrive when you're loading it in your browser will be such that the browser is actually able to show you a preview before when still 90% of the image needs to arrive. So that's a kind of trick to get the impression of quicker loading images.
Right.
Because by the time that you carefully look at the image, it will be completely loaded. Unless your network is really slow, then you might see that it's still loading. But as opposed to if it can only start showing something when everything has been transferred, that might introduce
right.
some more delay.
Well, and the 10% may be enough information for the user to already make a decision as to if to continue loading it or move on to the next thing, right?
Right. Yeah.
Right. Exactly. Cool. All right. Thank you.
So I'll talk about 2D images, but of course there are also 3D images, and there's various types of them. You have like stereoscopic, which is basically just 2 images, one for each eye. You have 360 images, which do some kind of mapping. There's also images that have depth maps. So basically, for every pixel, they say how far the pixel is away from the camera. There's also actual 3D models and actual 3D images with various technologies. So this is also very interesting, but it would lead me way too far to dig into those. There's another way in which you can have 3D images, which is when the third dimension is time, and then what you get is video, of course, or animation. And for video, I recommend to use video codecs because they are designed to do video. You can also use image formats to do what is called animated images, but it's not really a good idea. So, for instance, GIF or GIF is originally a still image codec, but it's now mostly known for its animations. But it's actually not a very good idea to use this, and it's better to use video codecs if possible, because they will compress much better and give a much nicer video quality. So I'll focus on just still images, 2D images, but of course 3D or video also exists. So that brings me to the second part, which is about color spaces. So basically, what is a pixel made of? And there are two main models. One is called RGB, for red, green, blue, and it's based on the way light works. And the other is CMYK, which is cyan, magenta, yellow, and black. And this is based on the way ink works. So one is based on light, and this is what is used in cameras and in screens, which are based on light. The other is based on ink, and it's used in printers. And fundamentally, the main difference is that light is additive. Adding two light sources will make things brighter, whereas ink is subtractive. If you combine two inks, things will get darker. For web delivery, you only need to think about RGB because everybody watches websites on a screen, not on a printer. They don't print it and look at it on paper. But CMYK is also quite important if printing is a use case. And you can convert CMYK to RGB, but not really the other way around. So CMYK has 4 components per pixel. It has a separate black, which is very useful for instance, text, which is typically black text, and it's typically encoded using just black ink instead of mixing colorings. But if you start from RGB and you go to CMYK, you need to somehow invent this for channel, which is not really possible, at least not in general. So for authoring, if print is going to be a use case, then this is often done in CMYK, but then for web delivery, you convert the CMYK to RGB because there's no need to transfer the extra component when all you're going to do with the image is view it on the website anyway. So RGB is what I'll focus on, but what does RGB really mean? Well, of course, everything depends on what is R, G, and B. And red, green, and blue need to be defined in some exact way. And the way this is done is by actually defining exactly what this color physically corresponds to. But there are various ways to do this. And the way you define where these primary colors are will define the color gamut. The gamut is basically the range of colors that can be reproduced, because you can reproduce a kind of triangle of all colors that you can get by mixing these 3 primary colors. But of course, the position of the primary colors will determine how many colors you can reproduce. So the gamut can be more narrow or more wide. The still most common color gamut is called sRGB, the standard RGB, which is standard gamut. But for instance, a lot of Apple devices use the P3 primaries, which gives you a wider gamut. There's various different color spaces that differ mostly in how they define the RG and the B. And for instance, in HDR televisions, you will typically also have a wider gamut called Rec 2020, which is even wider gamut than P3. So the wider the gamut, the more saturated and deep colors you can get, and the more colors in general you can reproduce. The other aspect, besides where the primaries are, is what is the dynamic range. So how bright is the brightest white? How dark is the darkest black? And here we distinguish between the standard dynamic range, where basically the difference between the darkest black and the brightest white is about 6 stops. 1 stop is a doubling of intensity. Whereas in high dynamic range, the difference can be maybe even more than 13 stops. So the darks are darker and the brights are brighter. And basically you can have more contrast in your image, and just a more accurate reproduction of the intensities in an image that gets closer to what we can do in what is available in the real world, let's say.
So with HDR, you can also get a lot more. I'm asking, you can get a lot more detail in the darks, right?
Yeah, typically yes.
Because you have all those extra, what is it, 7 stops, almost doubling of what you have in standard.
Yeah. So there are different standards of HDR, like in displays of when you can call yourself HDR, and one is mostly aimed at being better at the brights, but the other is mostly aimed at being better in the darks. And of course, ideally you have both, but typically like OLED based displays, they can get darker darks. And so they can get better contrast in the darks as well. So it's all nice to have more dynamic range, but this means you also need more precision when representing your pixel data. So precision is basically how many bits you use per pixel, or per sample value. And traditionally, in standard dynamic range, 8-bit was what was used. So 3 times 8-bit to be exact. Once for R, once for G, one for B. So this gives you 16 million colors overall, 2 to the power 24. But this is not enough anymore for HDR. So HDR screens are typically 10-bit or even 12-bit, which means you get a billion different colors or more. And while editing or altering images, you typically even use more precision than that, so that you have some headroom for editing. If you want to adjust the colors, that you can still do it without running into precision issues. So the precision that an image format supports is important also for its use cases. If you want to do HDR, you need to support at least 10-bit for delivery, and probably at least 16-bit if you want to do altering with it. All right. Besides RGMB, there's also very often another component called alpha, and alpha is just representing how transparent the pixels are. So by adding this virtual extra pixel component, you can make layers where some pixels are opaque and others are transparent. So that way you can overlay the layers in interesting ways, and you can create images that have basically any shape, as opposed to being always a rectangular grid of pixels. So this alpha channel is, of course, also something that the image format needs to support. It's very much used in authoring, but also in delivery. It can be useful to have images with an alpha channel so that they can blend nicely with the rest of the website design. All right, that's what I had about color spaces and color representation. So let's go to the final part about image formats themselves. So there are a lot of them, and I'm just going to try to organize and categorize them so that you can better understand what the differences are and when you need what. So different purposes for formats lead to different properties. And like I said, during authoring, you need lossless. You also need high color precision. So authoring formats will have just that. Another aspect of authoring formats is that they are typically proprietary because they are tied to specific software like Adobe Photoshop or Lightroom or whatever specific software. And the format itself reflects the features that are available in that format. Altering formats need to be quick to save because you don't want to wait a very long time to save your project. And you typically don't care that much if the files you get are very large because they're typically stored locally. Altering formats also need to be able to store metadata about the image so that you can keep track of this information. And they also typically support multiple layers that you need while editing. Whereas in delivery formats, you don't need these multiple layers. They are merged because more layers just means transferring more data. You don't need metadata either. You just need small files that are quick to load, quick to transfer. And they need to be interoperable. So for delivery, you cannot have proprietary formats that are not interoperable. They need to be standardized and implemented in the browsers. You don't need lossless necessarily for web delivery. Lossy is fine. Precision doesn't need to be super high because the main purpose is viewing the image, not editing it. So if we dig into a little bit more detail, there's actually on the altering side a difference between capture formats and altering formats. Capture formats are what cameras, for instance, themselves provide as a camera raw format, which is specific to the specific camera model. And this is really what you use to do the capture itself. And then you import this into, for instance, Darktable or Adobe Lightroom or tools like this. And then you start the altering workflow. In altering formats, you have basically one format per software package. There's, of course, the Adobe products that are very well known. There are other products. There's also open source alternatives for them like GIMP or Krita. And typically this software has a lot of features, and all of these features are somehow reflected in the format that corresponds to that software. And again, like I said, they don't really do compression. Maybe they do some weak form of compression, but it needs to be something that can be done quickly. Then on the delivery side, you can also distinguish between interchange formats and delivery formats themselves. So interchange is a kind of delivery, but it's a one-to-one transfer where basically you don't care that much about the file size. You mostly care about having something that the other person can open. So something that is not specifically tied to a specific software package like Photoshop, but something that will work in a lot of software, so in an interoperable format. A typical example of this is PNG, or PNG, as you should probably pronounce it, or TIFF is also well known. And so in these formats, you still might want to edit the image afterwards. So lossless compression is still used. But you do need to sacrifice some of the features of altering formats. So you don't necessarily have layers available anymore. You might need to rasterize some vector elements and so on. So it's for interchange, but not really for delivery. And then
real quick on that one,
yeah.
Jan, on the interchange, it sounds also that let's say if you're doing video editing and you need to show some images, interchange formats may be the right ones where you don't need all of the information from the authoring types, but you still need that high quality for your editing NLE, right?
Yeah, exactly. So you don't want to introduce any lossy compression yet, but you still want to do some lossless compression because these are not just temporary files that you locally store, but do typically want to store them for a longer time or send them to somebody else. So decent compression is useful, but typically only losslessly. And in delivery formats, then there you really do the lossy compression. This is also meant for transferring images, but not one-to-one, but one-to-many. So you might want to spend a bit more time on doing the encode, because it's going to be sent to many people and decoded many times. And also in these formats, progressive decode can be quite useful to make it look like it loads quicker. So examples of this are of course, JPEG is very well known, but also WebP, AVIF, and JPEG-XL are examples of formats that are useful for delivery. So to summarize everything in an overview chart, basically I've tried to collect some of the more important formats in this chart. The horizontal axis is raster versus vector. So on the left you have the raster formats, on the right you have the vector formats. And the vertical axis is authoring versus delivery. So on the top you have the authoring formats, on the bottom you have the delivery formats. And some of the formats are really very specific for one of these things, like WebP, for instance, is only doing raster, is aimed only at delivery. As the name says, it's a web picture, and it's designed only for that. Whereas other formats have a bit more different use cases. Let's say, like JPEG, for instance, is also kind of used as a capture format. A lot of consumer-grade cameras will take pictures in the JPEG format. It can be used as a kind of interchange format, and it can also be used as a delivery format. So it has a bit of a broader scope. I'm not going to go into all of the different formats because there are quite a lot of them, but this way of organizing them can help you to understand what is the purpose of a format and where does it fit. And of course, the distinction between authoring and delivery is not a 100% pure distinction for every format, and raster and vector as well can be combined. For instance, in a lot of vector formats like SVG, PDF, you can also have raster images that are embedded in them. So it's not because something is a PDF that it's necessarily a vector. It could be a PDF that only contains raster images. And also in some of the raster formats like Photoshop or GIMP, you do have some vector elements, like text layers typically in these formats, or paths are stored as vectors, not as rasters. Yeah, for instance, wide gamut and HDR that we talked about in the color spaces is typically something that is supported in the authoring formats, but not necessarily in all of the delivery formats. So, for instance, JPEG and WebP, they are limited to 8-bit, so they're not really suitable for these things that require higher color precision. Alpha transparency, for instance, is supported by most of the formats, but notably it's not supported by JPEG. So, of course, you need to take this into account. Yeah, I'm not going to go over all of them, but basically, if you need a specific feature, you can see what format support it, and typically this is driven by what they're designed for. Like web delivery formats like WebP, they don't support CMYK because you don't really need CMYK on the web, and so on. So that's my last slide. And I'd like to thank you for staying with me until here. I hope it wasn't too complicated.
It was fantastic. Great presentation, Jan. Thank you so much. Quick question for you. Do you see, is there a format, or do you feel there will be a format in the future that can be both used for authoring and delivery?
Yeah, so I mean, of course, the authoring software will always have a lot of features that
Right.
will be very hard to standardize, because with every new edition of their software, they will
New
bring new
features come.
features that
Yeah.
will also be reflected in the format. But I think it is possible, and in fact, I've been participating in standardizing JPEG XL, which is one of the most recent image formats that exist.
Hmm.
And XL in JPEG XL doesn't really mean that the files are larger, because that's not the point. But it's extra large in terms of features, and in terms of scope, in the sense that it is not just designed for delivery, but it can also do elements of authoring and interchange and capture. So it's a format that we hope will eventually be implemented in cameras to capture in this format, because it's HDR capable, unlike the old JPEG. But it can also be used as an interchange format for authoring, since it supports layers.
Right.
It supports things like CMYK, spot colors, all these type of features that you typically need at the authoring phase. And then it's also very optimized for delivery. This was one of the main things. So it's offering great compression. It's offering progressive previews. All these things that you want in web delivery. So in that sense, it's the first attempt, I think, to make a format that covers
Yeah.
the whole scope, and that might be able at some point to simplify the situation a little bit, where we don't need to have all these different formats for all the different purposes, but we can kind of standardize on one and just use it across the workflow.
Makes sense.
Um, but
Yeah.
we'll see how that goes. There's still a long way to go in terms of adoption.
Yeah, we know how the web industry loves to standardize on stuff, right? I'm just kidding. I'm being a little sarcastic there. All right, Jan, thank you so much. I really appreciate it. That was a great presentation, man. Appreciate it.
Thank you, and thanks for having me.
And thanks to the rest of you for watching. Remember to continue your journey learning all about digital asset management systems by watching the next lesson. Also, remember that there's going to be a study guide for this lesson. And if you use that, you'll be able to get your certification later on when we're done with the entire bootcamp. And as always, there's my email, marcelo@headlesscreator.com. So until the next lesson, cheers, everybody.